Alright, Miss Anderson, let's go ahead and get you caught up. We're going to go ahead and take a quick look at ellipses. Alright, so this is what we've been doing so far in class. Alright, with ellipses, I'm going to ask you to find a few things. I'm going to ask you to find the center, the foci, the vertices, the co-vertices, the length of the major axis, and the length of the minor axis. Okay? So these are the elements I'm going to ask you to find. Okay? Now, with an ellipse, what's going to happen is it's going to be one of two orientations, right? So there's going to be horizontal, right? And it's going to be vertical. Now, this is all governed by the whole thing of a squared minus b squared equals c squared. A squared is always going to be our largest denominator, so whichever number is largest on the bottom is automatically a squared. If a squared is underneath the x component, it will be horizontal. If a squared is underneath the y component, it's going to be vertical. Now, the center is going to be the same no matter which one you're looking at, right? It'll always be h comma k. We know that from the equation, just like from a circle. Very easy. Okay? Now, if it's horizontally oriented, what we're going to find is that whatever this number is here, k, is going to be the same number there. And it's going to be the same number here. And then for the co-vertices, whatever number is here for h is going to be the same number here. So this is kind of like my setup of what to expect. Okay? Now here, on the vertical side, it's going to be just the opposite, right? So here, whatever number I have for h here, it's going to be h right here. Whatever I have for h here, will be h right here. And then finally, whatever number I have for k here, is going to be k right here. So I can fill those in pretty much as soon as I recognize if it's horizontal or vertical. Now, to fill in the other numbers, what it's going to be is we're going to go with plus or minus c, plus or minus a, and plus or minus b. So here we can see h is missing, so what I'm going to do is I'm going to look at this number, whatever it is, I'm going to add and subtract c to get my ordered pairs. Here, h is missing, so I'll add or subtract a to get my ordered pairs. Now, conversely, if it's vertical, I'll be adding those to k instead of h. Right, so just kind of flip-flops. And then finally, my major axis is always going to be 2a. So whatever a is, I double it, and my minor axis is always going to be 2b. Okay? So this is kind of an overview of how ellipses behave. All right, let's go ahead and see it in practice by doing an example. All right? So this is number 1 from yesterday's assignment. We went over these in detail in class today. So we had the equation x minus 3 squared over 16 plus y minus 1 squared over 4 equals 1. Okay? So right off the bat, I can go ahead and figure out what h, k, a squared, and b squared are. So the center. The center is always going to be hk. So here this is x minus 3, positive 3. This is y minus 1, positive 1. Okay? Just like it was with circles. So there's the center. Now here, whatever one is larger is a squared. So I can see here that a squared is equal to 16. That means b squared is equal to 4. And then I know that c squared is equal to a squared minus b squared, which is 12. And now I can go ahead and take the square root of each of those, and I see that a equals 4, b equals 2, and c equals 2 root 3. So now I can start finding the rest of the information here. So for vertices, right? A squared is underneath x, so this is horizontal. So I know if it's horizontal, that 1 is going to remain the same. Same thing for the foci. So I should have done foci first. Alright? So this 1 will remain the same. Those 3 will be the same if it is horizontal. And then for the co-vertices, the 3 is going to remain the same. Now I just need to find the other numbers. For the foci, I use c, which is 2 root 3. So I'm going to take this 3, and I'm going to plus or minus 2 root 3. Those are actually 2 ordered pairs, even though we just express it as 1. Now for the vertices, I'm going to go ahead and use a, which is 4. So I'm going to do 3 plus 4, which I can simplify to 7, and I can do 3 minus 4, which is negative 1. So I get 2 separate ordered pairs, right? Notice there's 2 ordered pairs here, but we just write them once because it's plus and minus. Okay? And then for the co-vertices, I'm going to use b, and I'm going to have to use 1, So I'm sorry, so I'm going to do 1 plus or minus 2. 1 plus 2 is 3, and then 1 minus 2 will be negative 1. So those are my center, foci, vertices, and covertices. Now the major axis is pretty easy. I'm going to take A, which is 4, I'm going to double it. And then my minor axis, I'm going to take B, which is 2, and double it. So I know that my major axis is 8 units long, and my minor axis is 4 units long. Okay? Pretty straightforward once you see one done. We'll take a look at one more example. Another problem I asked students to do last night in the homework was problem number 3. Okay, let's go ahead and take a look at this one. For number 3, I've got x squared over 49 plus y minus 3 squared over 9 equals 1. So now here, I can go ahead and I can quickly identify h, k, a, b, and c. So I'm going to have my center, my foci, my vertices, my covertices, my major axis, and my minor axis. Should be able to just squeeze it on the page. So the center, what's being subtracted from x? 0. What's being subtracted from y? 3. So there's my center, 0, 3. Now again, a squared is underneath x squared. So again, this is horizontal. So I know that the 3 is going to remain constant here, and the 0 is going to remain constant there. Now I know that a squared is equal to 49, b squared is equal to 9, and c squared equals the difference, which is 40. So the square root of 49 is 7, the square root of 9 is 3, and the square root of 40, if I go ahead and simplify, will be 2 square root 10. So now I can fill in the rest of these numbers. Here it's going to be 0 plus or minus c, so just get plus or minus 2 root 10. Here it's going to be plus or minus a, so 0 plus 7 is 7, 0 minus 7 is negative 7. And then finally I'm going to use b, but it'll be 9 this time, so it'll be 3 plus 3, which is 6, and 3 minus 3, which is 0. Okay. My major axis is 2 times a, which is 14. My minor axis is 2 times b, which is 6. Alright, so again, hopefully you found those to be fairly straightforward. Where things get less straightforward is when the equation is not in the proper form. So let's go ahead and take a quick look at that. Okay, this is the last example. This is number 5 from the homework assignment from last night. We've got this equation here. This is number 5, sorry. That says 9x squared plus 4y squared minus 36x plus 24y plus 36 equals 0. So you can see this is nowhere near the same form as we've been looking at. So the first thing we have to do is get this in the right form. So again, I'm going to chunk my x's. I get 9x squared minus 36x. Leave yourself some space. Chunk my y's, plus 4y squared plus 24y, leave yourself some space. And then I'm going to move this 36 to the other side by subtracting it, so I get negative 36. Now I'm going to factor out this number in front of x squared, right? I need to get rid of it. So I'm going to factor it out. This becomes x squared. 36 divided by 9 is 4x. Leave your space, close your parentheses. Plus, factor out a 4, y squared. 24 divided by 4 is 6y. Leave yourself some space, close your parentheses. Equals negative 36. Now I need to go ahead and figure out what number am I going to add here. Half of negative 4 is negative 2. So I add negative 2 squared. Negative 2 squared is 4. 4 times 9 is 36. So over here I will have to add 36. Then the number that goes right here. Half of 6 is 3. 3 squared is 9. 9 times 4 is 36, so I need to also add 36. Now I can go ahead and I can bring this all down. So here I'm going to get 9 times x minus 2, the quantity squared. This just factors to x minus 2. Plus 4, and then this will factor to y plus 3, the quantity squared. Equals, and then over here, Negative 36 cancels with 36, and I'm left with the last 36. Okay. Now I don't want my equation to equal 36, I want my equation to equal 1. So what I'm going to do here is I'm going to go ahead and I'm going to divide this by 36. But if I divide this side by 36, I need to divide this side by 36 as well. These are going to cross out and become 1. Okay. Over here, 4 over 36 is going to reduce to 1 over 9. And then over here, 9 over 36 is going to reduce to 1 over 4. And now my equation is in the right form. Now I should be able to quickly identify the center, which is going to be the point 2, negative 3. Okay. I can see here that this is vertical. So because it's vertical, I know that the 2 is going to remain constant to start. Right, this is a little bit different than the last one we saw. And then here, when I get to the co-vertices, the negative 3 will be constant. Okay, so just fill that in. I can see here that a squared is equal to 9 because it's always the bigger number. Underneath y, that's what made it vertical. B squared is equal to 4. So c squared will equal 9 minus 4, which is 5. That means a equals 3, b equals 2, and c equals the square root of 5. Now for my foci, plus or minus c, so it'll be negative 3 plus or minus the square root of 5. Here will be a nice integer, so it'll be negative 3 plus or minus 3. Negative 3 plus 3 is 0. Negative 3 minus 3 is negative 6. And now for the co-vertices, I'm going to use b, which is 2, but I'm going to use the h value as well. So 2 plus 2 is 4. 2 minus 2 is 0. Now the easy one's the major axis. It's going to be 2 times a, which is 6. And the minor axis is going to be 2 times b, which is 4. Okay? Pretty straightforward. Feel free to watch this a couple times. Hopefully it makes sense. And then if you could, try to make sure you knock out those evens, number 2, 4, and 6 tonight for homework. Thank you.